This is section 16.3, and it's about continuous money flow. And so in some instances, money flows in and out of accounts almost continuously, like bank receipts, payments, store income, etc. The money's going all the time. And so we have a formula called the present value of money flow at time t. And it is an integral from 0 to the time you're talking about. F of x, you have a function, times e to the negative rx, r being a rate, dx. And then the accumulated amount of money flow at a particular time t, you take this p, the present value, which is this integral here, and you multiply it by e to the rt. So it's e to the rt times p, or it's this thing here. I mean, those are the same things. So those are the two formulas we're going to be doing. It's really just all calculation. We only have 3 questions. Each question has a couple of parts. Let's go look at our questions. So this is what the question would look like. The function f of x equals 500 represents the rate of flow of money in dollars per year. Assume a 5-year period at 5% compounded continuously. Find 2 things. A, the present value, that's that first formula, and B, the accumulated amount of money at t equals 5. So I'm going to go down here where I've got this one. So A, here's our formula. I just wrote it straight out again, and then when we go 0 to 5, our f of x is just 500 e to the negative 0.05 x dx. You can pull the 500 out, and then here is your integral. Remembering that the integral of e to the u is e to the u divided by, it's e to the kx over k. So you just have this 0.05, negative 0.05 underneath as well, and evaluated at 0 and 5. So we're plugging in 5 here, and then we'll subtract e to the 0 here. So we get this. What I would say is that you can do this with the calculator. We have learned to do Math 9. If I bring my calculator up, I have done this integral part with the 500 already pulled out, and I put it in 0 and 5 e to the negative 0.05x, so that's that piece, and then we have dx. I hit enter and got this 4.42 decimal number, and then I multiplied it by the 500. You get the answer that we get if we do it the long way. So at this point, you are totally capable of doing that. You do need to use your formula and get it set up, but you can do that. All right, then for the second part, the accumulated, there's the formula, but we've already figured out p, so we're just multiplying. This is a calculation. E to the 0.05 times 5, because we were given the year 5, times the number we found here, 2211.99. So our second answer is 2840.25. So that's how we do number 1. Let's go look at number 2. Number 2, we just have a different f of x, 1200 e to the 0.03x, so that's totally different than just a constant. And we have a 10-year period and 5%. So we're doing the same thing. Let's go down here. So formula written again. We've got 0 to 10, 1200 e to the 0.03x times e to the negative 0.05x dx. All right, so we'll pull if we're doing it by hand, we're going to pull the 1200 through. And if we multiply e times e, you're going to add those two exponents and you end up with negative 0.02x. And when you integrate, you have e to the negative 0.02x over negative 0.02 evaluated from 0 to 10. And I just put that little rule out there to remind you. And so you're plugging in. And what happened here, the x, the 10, made you move the decimal that place. E to 0 is 1. So if you do all of that and then multiply by 1200, we get this. For the second part, we're going to take that p-value right here and multiply by e to the 0.05 times 10. and you get 17,931.74. Now again, you could do this original part in Math 9. I am doing it by hand so that if you want to practice that, you certainly can. Number 3, let's look at question 3. It is just the same kind of thing. Here's our f of x, here's our 10-year period, and 8% compounded continuously. So let's go down and just kind of briefly look at 3. So, full formula there, 0 to 10, 800e to the 0.03x times e to the negative 0.08x. We pull the 800 through, and we have e to the negative 0.05x. We integrate, and we plug in 10, we evaluate it, 0 to 10, multiply by 800, we get this number. The second part of the question, we're going to take the 6295.51, multiply it by e to the 0.08 times 10, and we get this amount, $14,010.92. So really quick calculations, especially if you decide to use the Math 9. So that should get you through 16.3.